So I'm James Strachen. Just call me anything you like. James is good. Just call me James. I think open source has been proven as the way to build software. Pretty much all software that has any value is now open source. I've been a huge fan of open source for quite a while. For me, open source is about collaborating across corporate boundaries, right? It's a way of delivering software collectively. I think personally, though, one of the best things about open source is the best way for a developer to learn. I remember when I first got into software, I was desperate to get a real job so I could find out how stuff was really done, and was kind of disappointed when I went to a normal corporation doing software that there wasn't that much awesome software being written, and there's not that many amazing people in software. Whereas as soon as you get into open source, all the really good folks do stuff really well. There's something about open source that I think, because something's public on the internet, you tend to try a little bit harder with your code. So I think it's proven as the best way of building software, right? If you look at things like Docker and Kubernetes, they're amazing technologies built incredibly quickly by some of the brightest minds in our world. Kubernetes is awesome, right? It's really, really awesome. For me, Kubernetes is one of the most exciting open source technologies I've ever seen in my life. It's a complete game changer. I'm a self-confessed fanboy. It is an amazing piece of technology. I only wish I'd have thought of it, right? It's just amazing. It's really amazing. In many ways, what's awesome about Kubernetes is it's taking all of Google's knowledge for the last decade of running containers at scale and packaging it up into a surprisingly simple, smallish open source project so that anybody can run containers at scale like Google does. And what's amazing is now all of the big public clouds all support Kubernetes natively. What's also interesting is they use the same upstream distribution. So you can take the same distribution of Kubernetes, use it on Amazon, Google, Azure. You can run it on DigitalOcean, you can run it on your laptop, you can run it on OpenShift, you can run it on any machines you have, right? Being able to run containers at scale in a Google-like way on any machines, I mean, it's a complete game changer. For like a decade, we've had all of these discussions about is OpenStack going to win? Is that going to be the EC2 equivalent? And should OpenStack adopt EC2's REST APIs and all this kind of stuff? And that's kind of now all over, because really we have this Kubernetes abstraction, which I think the thing that I really like about it is it's really aimed at developers. It's aimed at making this DevOps line where developers use declarative metadata and put stuff in containers and run their apps. And then operations just keep the Kubernetes cluster running and keep the hardware running. So it's a really lovely balance between giving something that developers like and enjoy and is simple and easy to use and powerful, and letting ops automate the hardware and the persistence and the networking and load balancing and stuff. So Kubernetes is awesome. For me, as a software developer, I've been a software developer for like over 25 years. Kubernetes and containers is the biggest change in how to develop software that there's ever been, right? For me, it changes everything. I mean, this is why I'm so excited to be at CLOUDBEES and the various things we're doing at CLOUDBEES, because really once you adopt containers and cloud native and you move to Kubernetes, everything becomes different. How you package, how you deploy, how you deliver, how you install, how you use your mutable infrastructure, how you do rolling upgrades. There's a whole ecosystem of technologies like Prometheus and Istio of how you do service meshes, how you do operations. We're all becoming like mini Googles where we can run stuff like Google does, which using open source commodity stuff, which is truly amazing. And in many ways, the cloud's becoming a commodity now, which is truly awesome. The one lesson I got from Kazuki's building of the Jenkins community is by having the plugin model, it lets lots of different teams come along and build extensions to Jenkins completely isolated from each other, which really, really helps grow a massive community. So now there's a huge, monstrous community in Jenkins. One of the things I'm hoping going forward with Jenkins is we can start adding different kinds of plugins, so they don't have to be in the Jenkins master, right? Different microservices, different Kubernetes extensions and whatnot. So I'm hoping we can take that really healthy, vibrant community and going slightly different directions to make Jenkins and Kubernetes and various other technologies easier to use. So we can kind of broaden the horizon a little bit from not just CI and CD, which is a pretty huge spectrum just right there, but to the whole development ecosystem, right? From development, testing, real-time editing, debugging, right? I'm hoping Jenkins can really grow the community footprint to tackle all of these issues that exist, and Jenkins becomes the focal integration point between development, IDEs, testing, debugging, metrics, and so forth. Jenkins X. So Jenkins X is hopefully going to be a sub-project in the Jenkins Foundation. That's the aim. And the basic idea of Jenkins X is to focus purely on how do we make continuous delivery and Kubernetes easy to use from using Jenkins under the covers. So it's really about, we want to take continuous delivery and continuous integration and make it an appliance that just works for any developers. Jenkins is amazing, and you can use Jenkins to do anything. Build mobile apps, build containers, use Kubernetes, use Docker, use whatever, right? You can do anything in Jenkins. One of the tricky bits, though, is Jenkins has never been that opinionated. You know, you create a new pipeline and it's empty, and you have to figure out what plugins to install and how to do CI and CD and all these kind of things. What Jenkins X is trying to do is really automate the Jenkins part. So you just import your app, you get a pipeline, it does CI, it does CD, it does pull requests, it does promotion across environments. It gives you an out-of-the-box staging, testing, and production environments. It promotes your app through them. It uses, semantic versioning for all your releases. It uses under the covers technologies like Helm and Draft and Kubernetes. But it just automates everything. So you don't need to know anything about Kubernetes or Docker or what Helm even is. Everything just kind of works out of the box. So we're really trying to help people move to this new world of containers and Kubernetes and CD, and just get started from day one. There's a whole trend in software now around microservices, which is really about how do we help teams go faster by having little small projects that just release independently. As soon as you move to a microservice world, you soon go from having one release to like 10 releases to like 100 releases. To soon you have like 1,000 Git repos with all different microservices inside them, and each one could be releasing independently. You need a simple way of just automating all of the CI and CD across hundreds of repos, right? And that's really what we're trying to do with Jenkins X, make it super simple that people can just spin up a Kubernetes cluster, install Jenkins X on it, import some projects, create some new projects, and have full CI CD, and then basically go faster. Well, all businesses and teams will start with some monolith kind of apps, and many teams now want to do more microservices stuff. So it might be a new business function. You think, well, we'll do a microservice for that new thing, or we'll maybe take this one piece of the monolith out and we'll make a microservice there to dip our toes in the water in this microservice thing. I mean, the main reason people go down this cloud native and microservice route is to go faster, right? Monoliths can get really big and slow to release because it's huge, it's complex. The bigger software gets, the slower it takes to release, and the more risk and so forth. So I think everyone is pretty much on the same page that microservices are the way to go faster for most people. But what's interesting is with Kubernetes, you can deploy monoliths and microservices, right? So with Jenkins X, we can take any app. It could be a monolith, it could be using WebSphere, WebLogic, Tomcat, JBoss, whatever, Node, Go. It doesn't really matter what the app is, we can deploy it on Kubernetes. So Jenkins X can take any app and deploy it. Okay, the more monolith and legacy, we might need to tweak the Docker file a bit, but that's no big deal. So I think Jenkins X gives us an excellent opportunity to take what you have and build it on Kubernetes and go through the environments, and then over time refactor pieces out into smaller and smaller modules. One of the challenges, we've been doing lots of microservices, myself and the team I'm in for the last kind of few years. One of the interesting things is you start to move to a more decoupled microservices kind of model, and you, for example, take one big UI and you split it into node modules or whatever, or one big monolithic app and you split it into jars or wars or whatever packages. You soon have lots and lots of repos that are releasing all the time, and you have a trouble. How do you keep everything in sync? And when I've released a new version of a base library, how do I update my downstream thing with a new thing? And then how do you do dependency updates in a way that goes quickly? One of the other technologies in Jenkins X is something called UpdateBot, which what we basically do is whenever you do a release, your release pipeline will do a versioned release of a new node module or Docker image or jar or whatever. It will then go through all of the repositories in the organizations that you've defined and go through all the repositories to find anything that uses your library or jar or package or Docker image or Helm chart, and then it generates a pull request. And then the pipeline waits for that pull request to merge. So what happens is, if I edit and release a new base library, my pipeline waits to make sure that all of those pull requests merge so I haven't broken anything, and then I get a green. so that it helps the feedback between teams. One of the things we found really common is once you start having lots of pieces that all link together, someone working on a base library could break everything. And without that feedback loop, they have no clue. And then 3 months later, somebody else upgrades and everything's broken. And then they get angry and cross and they don't know what's changed. The more we can do continuous delivery, even between libraries, right? I mean, from a library, production is a POM XML or a package JSON, right? You deploy to POMs more than Docker containers. So one thing we found is this update bot idea of aggressively pushing via pull requests changes to software drastically optimizes the feedback loop and the cycle. It's a little bit like the whole idea of continuous delivery. Have lots of small changes, go to production immediately, so you're doing lots of small increments, so it's zero risk. If anything goes wrong, you know exactly what you just changed, so you know how to fix it. And you get feedback because the person who's just made the change gets notification that they just broke everything. So I'm hoping over time we can get most open source projects to adopt update bots, so that as Spring or Hibernate or Groovy or Camel or whatever is releasing, other open source projects can get automatic pull requests to keep them on the latest version to avoid CVEs and security issues and bugs and whatever. And then once that starts happening, hopefully we can extend it to people doing on-premise stuff, so we can generate automatic pull requests to upgrade your applications. What we're building at the moment is a continuous delivery platform that really makes continuous delivery just super simple, right? As developers, we've had IDEs for quite some time, which work great on your laptop. When you have source code on your laptop and you're editing on your laptop, an IDE is awesome. What we're trying to build is almost like a continuous delivery environment, like the next level of how do we look across multiple Kubernetes clusters, multiple Kubernetes environments, multiple microservices, each having different releases and versions and pipelines, and watching the flow of code changes and releases across environments, helping you see when one code change starts to go bad in staging, or you want to do canary deployments in production or whatever, right? As soon as people move to this new microservices world and start adopting Kubernetes and cloud technologies, suddenly the kind of complexity from a developer gets hard, right? You have all these different Kubernetes clusters to understand, all these different namespaces, all these different resources, all these different operational metrics and monitoring happening, all these different releases happening. It can be really hard to figure out what's going on, right? So what we're really trying to focus on is building a single pane of glass, which will help you visualize Kubernetes, Jenkins X, various open source things like Prometheus and Grafana, various Helm things like Helm chart repositories. Visualize all this stuff in a simple, easy to use web console. So it's very much like a DevOps IDE of sorts, right? Use your IDE to edit code, but once you've done a commit, we want to give you a lovely user experience to navigate what you're doing, what your teams are doing, what the effective pull requests are, and the whole flow from code to production, right? We want to visualize and automate all of that.